Bismillah ar-Rahman ar-Rahim. Now we start 5.9, hyperbolic functions. What we have these functions. Sine hyperbolic is e to the power x minus e to the power minus x over 2, and cosine hyperbolic e to the power x plus e to the power minus x over 2. These are new functions. They call them hyperbolic functions. Why they call them hyperbolic functions? Because they have this relation, which is like similar to the hyperbola. Also, why they call it cosine hyperbolic or sine hyperbolic? Why they give it these names like the trig functions? Because if you look at the properties they have, it's almost the same as the cosine hyperbolic. I like the trig functions. Also, they define the tan hyperbolic, like sine hyperbolic. The same idea, like the trig. So the name sine to the trig functions. To the trig functions, and just they have only the name. So just we need to consider sine hyperbolic as this: e to the power x minus e minus x over 2, cosine hyperbolic as e to the power x plus e minus x over 2. That's a new function. They have some properties. Cosine hyperbolic square minus sine hyperbolic square is equal to 1. Tan hyperbolic square plus secant hyperbolic square is equal to 1. If you look at the sine hyperbolic double x, that will be 2 sine hyperbolic x cosine hyperbolic x, which is similar to sine to x equal to x, 2 sine x cosine x. And these, some of them are similar. This one is similar to what I have for the trig functions. This one, I think the sign, you need to change the sign, something like that. These are the graphs for these functions. This is the sine hyperbolic. If you notice, the sine hyperbolic is similar to what? Similar to x cubed somehow. So the domain is minus infinity to infinity, and the range minus infinity to infinity. Cosine hyperbolic. Now, if you notice, this is similar to x squared plus 1 somehow. So the domain is minus infinity to infinity, but the range is from 1 to infinity. Tan hyperbolic, the domain is still minus infinity to infinity, but the range is minus 1 to 1, where minus 1 open, 1 to open, where I have horizontal asymptote, y equal 1 and y equal minus 1 as horizontal asymptote. Okay. And the same thing for cosecant hyperbolic. Now, it's what? The domain is minus infinity to 0 and 0 to infinity, and the same thing as the range. Yeah, this is secant hyperbolic. If you notice, it's a number between 0 and 1, where 0 open and 1 closed. The range of this secant hyperbolic, and this is the cotan hyperbolic. Okay, so these are some of the identities related to that. You need to notice these two, which is a new ones. If you notice cosine hyperbolic x, we said this is cosine hyperbolic x, and then sine hyperbolic x is the same but with a minus sign. So if you add them, then e to the power minus x will be cancelled. So I have 2ex over 2, which is e to the power x. If we subtract them, then e to the power x cancels. So you have e minus x. Okay. Sine hyperbolic, if you know, which is this, if we differentiate it, you're getting what? E to the power x plus is minus x over 2, which is cosine hyperbolic. And the same thing, if you differentiate this, you are getting this. So derivative of sine hyperbolic, if you have u as a chain rule, then cosine hyperbolic of u times u prime. Cosine hyperbolic of u, that will be sine hyperbolic of u times u prime. Tan is secant square. So tan hyperbolic is minus cosecant square, minus cosecant hyperbolic square. If you notice secant hyperbolic x, there is a minus sign here. Not similar to trig functions. Also, the cosine hyperbolic, there is no minus sign here. Huh? Remember, the derivative of cosine x is minus sign. Here, I don't have minus. I think this is the two differences with regards to the derivative of the trig functions. And the integral will be the same thing. Okay, now we'll do some problems. He said if tan hyperbolic of x equal 4 over 5, I want to find the other hyperbolic functions. Clearly, cotan hyperbolic is very easy, which is 1 over tan hyperbolic. That will be 5 over 4. Okay. Then also, if you look at the relations, I have this, where I'm relating the tan hyperbolic with the secant hyperbolic. So I'll use that. I have 1 minus tan hyperbolic square equals secant hyperbolic square. Or in other words, which is this one. Secant hyperbolic square equal 1 minus tan hyperbolic square. So that I can find it. Is 1 minus tan hyperbolic square. And that will be 1 minus 16 over 25. That will be what? 9 over 25. So secant hyperbolic will be plus or minus 3 over 5. I will not take the minus. Why? Because if you notice from the graph, secant hyperbolic is always between 0 and 1, where 1 closed, 0 open. So for sure, I have secant hyperbolic will be only 3 over 5. If that's secant hyperbolic, that means cosine hyperbolic will be 5 over 3. What else remaining? Cosecant and sec and sine. I can use the relation tan hyperbolic equals sine hyperbolic over cosine hyperbolic. That means sine hyperbolic is tan hyperbolic times cosine hyperbolic. Tan hyperbolic is what? 4 over 5. This is 5 over 3. So that's 4 over 3. That implies in cosecant hyperbolic is equal to 3 over 5. Okay. Now, if I want to find the numerical value of some of these functions, sine hyperbolic of 0, sine hyperbolic of 0, that will be e to the power 0 as a formula minus e to the power minus 0 over 2. That will be 1 minus 1 over 2, and that is 0. Cosine hyperbolic of 0 at 0, that will be e to the power 0 plus e to the power minus 0 over 2. That will be 1 over 1 over 2, and that is 1. Cosine hyperbolic of ln 5, that will be e ln 5 plus e minus ln 5 over 2. Can I simplify it? Yes, because this is e to the power ln 5, that will be 5, plus e to the power ln 5 to the power minus 1 over 2, which is 1 over 5. So that gives me what? 5 plus 1 over 5 over 2. And that is what? 25 plus 1 over 10. That's 26 over 10. That's 13 over 5. The last one, cosine hyperbolic of 5, that e to the power 5 plus e to the power minus 5 over 2. I don't think you can simplify it further. I mean, like this one very clear you can simplify since I have relation the e with the ln. Okay. Now we need to differentiate these functions. Let me do it one by one. The first one, what will be y prime? It will be secant square tan hyperbolic of u, secant square of u times derivative of u. My u is 4x. That will be secant hyperbolic of 4x, derivative of 4x, which is 4. 2. Y prime will be what? Now I have a product rules. So I have x times, this is sine hyperbolic ln x, or I think I can simplify the function. Maybe it's better. Since cosine hyperbolic with ln x, I think I'm getting some simplification. That will be x, e ln x plus e minus ln x over 2. That give me what? X times, here I have x, here I have, this will go as a power, plus 1 over x over 2. So that give me what? X, I have x squared plus 1 over 2x. So the answer is x squared plus 1 over 2. That is y. So it will be y prime. Or I can write it better, half x squared plus half. So it will be y prime will be x. Correct? Yeah, y prime will be x. So I simplify the function. I'm getting this, which is easy to differentiate. Okay, 3. It's sine hyperbolic x squared plus x. There's no simplification here. So y prime would be cosine hyperbolic x squared plus x times derivative of this, which is 2x plus 1. 4. Y prime will be what? Cosine of cosine hyperbolic x times sine hyperbolic of x, which is the derivative of this. 5. Y will be what here? I have secant hyperbolic of x plus cotangent hyperbolic of x. Let me do the calculations. That give me, be sure that I'm not missing anything. Just a matter of differentiation. It's minus 2. Don't forget, huh? There is a minus sign. For secant hyperbolic, there is a minus sign. So it's minus secant tan. So I have minus 2. It's u square minus 2u. Derivative of u, derivative of this, which is secant. Actually, it's not minus. It's 2 secant hyperbolic x times derivative of this, which is minus secant hyperbolic tan hyperbolic x. Now I need to differentiate this. This is what? If you remember, the cosecant hyperbolic, or is the cotan, huh? Cotan hyperbolic is minus cosecant hyperbolic square. That will be plus 2 cotan hyperbolic x, derivative of this, which is minus cosecant hyperbolic square x. Okay, just leave it like this. Or you can write it minus 2 secant hyperbolic square tan hyperbolic x minus 2 cotan hyperbolic x cosecant hyperbolic square. Okay. What is this? 6. Y equal this. So y is secant hyperbolic of x square all square. So it will be y prime 2 secant hyperbolic x square times derivative of this, which is minus secant hyperbolic x square. Let me give it some space and write it here. That implies in y prime 2 secant hyperbolic x square times derivative of this minus secant hyperbolic x square tan hyperbolic x square times derivative of x square, which is 2x. So that give me what? Minus 4 secant hyperbolic square of x square tan hyperbolic x. Yeah, tan hyperbolic of x square. 7. E to the power secant hyperbolic, that will be e y prime, I mean, e to the power u times derivative of u, which is minus secant hyperbolic tan hyperbolic x. Yet, e to the power secant hyperbolic, this is the product rule. So it's e to the power x secant hyperbolic x plus e to the power x, derivative of secant hyperbolic, which is minus secant hyperbolic tan hyperbolic x. Yeah, I think it's very clear. 9, the last one, ln of sine hyperbolic of t, that will be y prime will be 1 over sine hyperbolic times derivative of this, which is cosine hyperbolic. So that will be cotan hyperbolic t. Now check these limits. For the tan hyperbolic from the graphs, the limit is goes to infinity is 1. The limit that goes to minus infinity is minus 1. So this is easy. That will be 1. And that will be minus 1. For sine hyperbolic, go back to the graphs. Sine hyperbolic is goes to infinity, it goes to infinity, and this goes to minus infinity. That will be infinity, and that will be minus infinity. For secant hyperbolic, secant I'm doing only x goes to infinity. As x goes to infinity, secant hyperbolic, y is going to what? It's going to 0. So this is equal to 0. Cotan, as x goes to infinity for cotan hyperbolic, what will happen? Cotan hyperbolic, this is the graph for cotan hyperbolic. As x goes to infinity, it's going to what? It's going to 1. That's going to 1. Yeah. That's equal to 1. Now this goes to 0 from right, x goes to 0 from left. Let me check. For cotan hyperbolic, x goes to 0 from right. I'm going to where? I'm going to infinity. X goes to 0 from left, I'm going to where? To minus infinity. So it's infinity and minus infinity. Yeah, from the graph. This is infinity, and this is minus infinity. Cosecant, as it goes to minus infinity, cosecant, that is cosecant. As it goes to minus infinity, I'm going to what? I'm going to 0. Very clear, I'm going to 0. Yeah, from the graph. You can do it by the calculation, but this is from the graph. Now to do this, I need to do it by the calculation. Limit goes to infinity. Sine hyperbolic x over e to the power x. That will be limit x goes to infinity. E to the power x plus e minus x over 2ax. So now I can simplify that, which is only ax over 2ax plus e minus x over 2e to the power x. So I'm getting half plus 1 over 2 e to the power 2x. Don't forget the limit. So this is goes to 0. E to the power, this goes to 0. So I have half plus 0, which is half. Okay, what is this? Find the derivative. I need to do the derivative for some functions. Okay, let us do it one by one. 32 what will be G prime? It will be 2 sine hyperbolic x cosine hyperbolic x, which is, if you notice, that will be sine hyperbolic 2x. Okay. No result. Okay. 33 is from the old book, huh? H prime will be cosine hyperbolic of x squared times 2x. 34, I think we did it before. Capital F prime at t will be sine hyperbolic of t, and this is cosine hyperbolic of t, so that will be cotangent hyperbolic x. 35. Capital G prime at t will be cosine hyperbolic of ln t times 1 over t. By the way, this you can simplify. This is e to the power ln t plus e to the power minus ln t over 2 times 1 over t. And that give me what? T plus 1 over t over 2 times 1 over t. And that give me t squared plus 1 over 2t times 1 over t. So it will be t squared plus 1 over 2t squared. Okay. 37. What will be y prime? It will be e to the power cosine hyperbolic 3x, derivative of this, which is sine hyperbolic 3x, derivative of this, which is times 3. The last one, this is 39. It's a product rule. So you have t, you make it t prime at t, small gt. That will be product rule, derivative of t is 1 times second one plus t, derivative of this. What's the derivative of cotangent? It's minus cosecant square root t square plus 1. Are we done? No. I need to find the derivative of this, which is 1 over square root t square plus 1 times 2t. So the answer is cotangent hyperbolic square root t square plus 1 plus. This is cancelled. That will be minus. So it's minus t square cosecant hyperbolic square over this. Okay, that's it. Now find the relative extrema, which I need to find the derivative and check the critical numbers, check if there is a change in the sign of f prime or not. Okay, to find the relative extrema. So I have f prime, product rule, derivative of the first one times the second, plus x minus 1, derivative of cosine hyperbolic, which is sine hyperbolic, minus cosine hyperbolic. That give me x minus 1 times sine hyperbolic x. That will be f prime. So critical numbers, I'll make f prime equal 0. The domain is all real numbers, huh? The domain of f is all real numbers, okay. That implies x minus 1 sine hyperbolic x equals 0. That implies x equal 1 or sine hyperbolic x equals 0, which means x equals 0 only. So I'll make this is 0. This is 1. Now check the sign of this. This is my f prime, huh? F prime is x minus 1 sine hyperbolic x. So this is what I will work out. I know that sine hyperbolic of x is positive if x is positive, negative if x is negative. So I take a value, negative value here. So that will be negative. And that will be negative. Take minus 2, for example. That will be negative times negative. That will be positive. So 0 and 1, that will be positive. This one sine hyperbolic will be positive. Half minus 1, that will be minus. Positive, positive, that will be positive. So it's increasing decreasing, increasing. So I have relative max here, and I have relative min here. Okay. Power cables are, yeah, this is a question in the book. Power cables are suspended between two towers, forming the town shown in the figure. The equation is this. What they want? The slope of this. So you have to find the derivative. Find the derivative at, yeah, what will be y prime? That will be a times sine hyperbolic x over a times derivative of this, which is 1 over a. So it will be sine hyperbolic x over a. Okay. Now, you want what? I want to find the right-hand tower, huh? Well, what's going on? You have this. This is called it. So you have this. Well, I have A here. I have the tower here. One tower here is minus B. Another tower here, which is at B. So he wants the right. He wants the slope of the content at the point where the cable meets the right-hand tower. When it meets the right-hand tower, it means x equal B. So he wants y prime at x equal B. That will be sine hyperbolic B over A. He said the right-hand tower. Okay. Prove the identity. I have to prove this identity. 1 minus sine hyperbolic over 1 plus sine hyperbolic is equal e to the power 2x. Check that. I will do left-hand side. I have 1 minus tan hyperbolic x over 1 plus tan hyperbolic x. Note that tan hyperbolic x is what? Is sine hyperbolic x over cosine hyperbolic x. If we do it as an exponential function over 2, that this over 2. 2 cancelled, so I'm getting this. Okay, let me plug the numbers. Getting 1 minus, and do the calculation, over 1 plus the same quantity. Now do the simplification. That will be over this e to the power x plus e to the power minus x minus e to the power x plus e minus x over yeah, let me see what will happen. Over e to the power x plus e minus x plus e to the power x minus e minus x over this. So this is cancelled. I'm getting what? This is cancelled. I'm getting e minus. No, I'm getting 2 e minus x over this is cancelled over 2 e to the power x. That give me strange. I think there is a mistake somewhere. Maybe the mistake in the statement itself. Non-hyperbolic is sine hyperbolic over cosine hyperbolic. And that e to the power x minus over plus. That's correct. So should be 2 2 cancelled. Huh? So I should get is minus 2x. So I think there's a minus sign missing here. Yeah. I think there should be a minus sign. Is it? Yeah. Yeah, it cannot be. I have sine hyperbolic, which is the negative, over the positive. This is the tan hyperbolic. Okay. So I think that should be a minus sign. B, I need to find f prime that over cosine hyperbolic x, derivative of that sine hyperbolic x, that give me tan hyperbolic x. Okay. Find the value of this. Sine hyperbolic 2 ln x plus cosine hyperbolic 2 ln x. If cosine hyperbolic ln x equal to. Okay. What shall I do? Cosine hyperbolic ln x is what? Is e to the power ln x plus e to the power minus ln x over 2. That give me x plus 1 over x over 2. Okay. That give me x squared plus 1 over 2x. Okay. That will not help. Now, if we go back to the formulas, where is the formulas? These are the formulas. Yeah, I know that sine hyperbolic 2x is equal to this, and cosine hyperbolic 2x is equal to this. 1 plus 2 sine hyperbolic square. Yeah. Okay. So this one, I know sine hyperbolic of 2 ln x, that will be 2 sine hyperbolic of ln x times cosine hyperbolic of ln x. Okay, I don't know, this is 2. No, this is 2. Okay. That would not help if that equal to 2. So I have x squared minus 4x plus 1 equal minus 4x plus 1 equal to 0, which you cannot solve. Okay, so I need to use the identities then. Also, I have cosine hyperbolic of 2 ln x. I look at the formulas. I want the formula with the cosine hyperbolic, since I know it. That will be 2 cosine hyperbolic square minus 1. That is 2 cosine hyperbolic square ln x minus 1. Okay. I get this. I know this. I know this. The remaining is this. How to get that? Okay. I know إنه cosine hyperbolic square of t, consider t equal to x, huh? Let t equal to x. Minus sine hyperbolic square of t equal to 1. And sine hyperbolic square will be what? Cosine hyperbolic square of t minus 1. So now sine hyperbolic square of ln x will be cosine hyperbolic square of ln x minus 1. Cosine hyperbolic square is what? 4 minus 1, that will be 3. So that means, sorry for all of that. Yeah, there is a quick way. Yeah, no need for all of these things. What is it? Yeah, look, we waste our time for something and we are going in a circle. What we did is correct, but there is a quicker way to do it. What is that? Look at the formulas again. Yeah, we have these formulas, 4 and 5. Cosine hyperbolic of anything plus sine hyperbolic is equal to e to the power that things. Yeah, so I have this equal e to the power 2 ln x, which is x squared. Okay. Which is x squared. Correct? Yeah. This will be your t. This is t. Sine hyperbolic t plus cosine hyperbolic t. It will e to the power t. It will in 2, so that will be x squared. خلاص. Now, cosine hyperbolic of ln x is equal what? E ln x plus e is minus ln x over 2. So that implies that equal to what? That equal to x plus 1 over x over 2. That is equal to x squared plus 1 over 2x. That equal to 2. So I have x squared minus 4x plus 1 equal to 0. I can solve this. X is what? Minus b plus or minus b, I mean, minus b. So it's minus 4 plus or minus 16 b squared minus 4ac over 2. That give me 2 plus or minus square root of 12. So if x equal 2 plus square root of 12, I want x squared in all the cases. What will be x squared? It will be 2 plus square root of 12 square. Yeah. Also, I notice here x equal to, that will be what? 4 plus 4 square root of 12 plus 12. That will be 16 plus 8 root 3. Yeah, that will be 4 to 8 root 3. Now, if x equal 2 minus square root of 12, this will be rejected. Why? Because ln will not be defined. Okay. Then x, I have x is positive. I need x to be positive. So that will be my answer. Okay. Same idea. Cosine hyperbolic 3x plus sine hyperbolic 3x equals 27. Notice this is what? This is e to the power 3x equal 27. So take ln of both sides. That will be 3x equal ln 27. So x will be 1 over 3 ln 27 So x will be ln 27 to the power 1 over 3 cubic root of 27, which is 3. So that will be x. Now sine hyperbolic of x will be sine, it will be sine hyperbolic of ln 3, which is my x. That will be a ln 3 plus a minus ln 3 over 2. That will be 3 plus 1 over 3 over 2. 9, 10 over 6, that is 5 over 3. Okay. If tan hyperbolic ln x equal 1 over 3, then find the value of this. The value of this is what? It will be ln e to the power x, which is x. So that x. So actually, I need to find x. Tan hyperbolic ln x, if you notice, tan hyperbolic of ln x will be what? It will be e of ln x minus e of minus ln x over e ln x plus e is minus ln x. So it will be x minus 1 over x plus 1 over x. That will be x squared minus x over x squared plus x. If this is equal to x, I'm getting what? I'm getting x squared. No, it's not equal to x, equal 1 over 3. I want this to be equal to 1 over 3. Can I solve for x? I'll do the calculation. So I have 3x squared minus 3x equal x squared plus x. So that implies 2x squared minus 4x equals 0. So take 2x common factor. The remaining is x minus 2 equal to 0. So I have x equal 0 or x equal 2. I'll reject this. Why? Because the link cannot be defined. So the answer is x equal 2. So ln of cosine x plus sine hyperbolic x will be ln e to the power x, which is 2. So the answer is 2. Okay. If tan hyperbolic of x is 3 over 5, find cosine hyperbolic 2x. Okay. To find cosine hyperbolic 2x, I have many formulas, but I need this formula maybe better. Since if I know tan hyperbolic, I can get what I will do. From here, I can get secant hyperbolic, so I can get cosine hyperbolic, then I can get cosine double x. So I have 1 or secant hyperbolic square of x. That will be 1 minus tan hyperbolic square of x. That will be 1 minus 9 over 25. That will be 16 over 25. So secant hyperbolic x will be 4 over 5. That means cosine hyperbolic of x is 5 over 4. Okay. That means cosine hyperbolic of 2x, which is 2 cosine hyperbolic squared minus 1. Look. Yeah, this one. خلاص. I plug the numbers and I get the answer. Notice here I took only the positive value, because the negative cannot be for secant hyperbolic. That will be 2, 5 over 4 square minus 1. That will be 2 times 25 over 16 minus 1. That will be 25 over 8 minus 8 over 8. That will be 17 over 8. Okay. Find f prime. Okay. Yeah. I'll do these two, then I will find f prime for this function. This It's just a quotient rule. F prime will be what? Derivative of the numerator, cosine hyperbolic, times the denominator, minus the denominator. That will be minus sine hyperbolic times the numerator over this square. Okay, numerator is what? Cosine hyperbolic minus cosine hyperbolic square plus sine hyperbolic square over 1 minus cosine x all square. This is what? This is minus 1, correct? Yeah, I know cosine hyperbolic square minus sine hyperbolic square is equal to 1. So sine hyperbolic square minus cosine hyperbolic square, that will be minus 1, which is here. So I have cosine hyperbolic minus 1 over this, which is this can be written minus 1 minus cosine hyperbolic x over this one, provided cosine hyperbolic not equal to 1, so x not equal to 0, so x not equal to 0, that will be cancelled. So I have minus 1 over 1 minus cosine hyperbolic x. Okay, now I have this one, 2. I can get the secant hyperbolic square, which is, if you remember the formulas, this is what? 1 minus tan hyperbolic square. So it's 1 minus tan hyperbolic square x. So it's 1 minus 2 over 3. That will be 4 over 9. That will be 5 over 9. So secant hyperbolic, yeah, 4 over 9. That will be 9 minus 4. That secant hyperbolic will be square root of 5 over 3. So cosine hyperbolic will be 3 over square root of 5. So sine hyperbolic, I need the sine now. I know cosine. Sine hyperbolic will be tan times cosecant hyperbolic. Tan is minus 2 over 3 times 3 over square root of 5. That will be minus 2 over square root of 5. So that implies, I know sine hyperbolic of 2x, that will be 2 sine hyperbolic x cosine hyperbolic x. That will be 2. Sine hyperbolic x is minus 2 over square root of 5. Cosine hyperbolic x is 3 times square root of 5. That gives me what? Minus 12 over 5. That will be the answer. Okay. For the second part, this is 1. This is 2. Okay. Last one before I stop. Secant hyperbolic equal 2 over 3. That means cosine hyperbolic equals 3 over 2. That means cosine hyperbolic 2x will be 2 cosine hyperbolic square minus 1. That will be 2, 9 over 4 minus 1. That will be 9 over 2 minus 1, which is 7 over 2. That's it. Yeah. Okay. Can I do more problems? Yeah. I think I can do more problems. Yeah. Let me do more. Cosine hyperbolic 3x minus sine hyperbolic 3x equals 3. If you look backward, I need which formula? I need this formula. Cosine minus sine, which is e to the power minus u. So I have e to the power minus 3x equals 3. So that implies take ln. I have minus 3x equal ln 3. That implies 3x equal minus ln 3. Actually, I need minus ln 3. I need 3x. So that means sine hyperbolic of 3x will be sine hyperbolic sine hyperbolic of minus ln 3. And that will be e of x. That will be my x minus e was minus my minus x e to the power minus x over 2. That will be 1 over 3. This is minus minus, so it will be plus e to the power ln 3, which is 3 over 2. So it will be 1 minus 9. That will be minus 8 over 6. And that is minus 4 over 3, which is this. Okay, if x is positive, tan hyperbolic ln x will be e to the power ln x minus e to the power minus ln x over 2 over 2 cancelled. So I have x minus 1 over x plus 1 over x. That will be x squared minus 1 over x squared plus 1. Now take it over x, this will be cancelled. So this is the answer. Yeah. This is maybe a little bit complicated. I know that the number of points at which the tangent line has sloped this. So I need f prime equal to minus 2. Take f prime of this. F prime would be what? 4 sine hyperbolic x minus 2 cosine hyperbolic x. I want this to be equal to minus 2. Okay, now we'll change it into exponential. I cannot use the rules since the coefficients are not the same. Huh? So I need to change the exponential. I have ax minus is minus x over 2. This one ax plus is minus x over 2 equal minus 2. That give me what? 2 e to the power x minus 2 e to the power minus x minus this is cancelled minus e to the power x minus is minus x equal minus 2. So I have what? E to the power x plus 2 minus 3 is minus x equals 0. Now multiply by e to the power x. I'm getting what? E to x plus 2 e to the power x minus 3 equals 0. I can factor it. That will be e to the power x plus 3 times e to the power x minus 1 equals 0. 2 minus 3, خلاص. So that e to the power x plus 3 equals 0, which is impossible. Or e to the power x minus 1 equal to 0. So I have e to the power x equal 1. Take ln. I have x equal ln 1, which is 0. So I have only 1 point. This is only 1 point. What x equals 0. Sine hyperbolic of this is equal to 3 over 4, and I have this information for specific function f. I want this. So I'll differentiate with respect to x. This is implicit differentiation. Sine hyperbolic of this, that will be cosine hyperbolic of this times the derivative of the product rule. I have f of x plus x f prime of x plus cosine hyperbolic of x equals 0. I will let x equal ln 2. I'm getting what? Cosine hyperbolic of ln 2 f of x, f of ln 2, not f of x, f of ln 2 times f of ln 2 plus ln 2 f prime of ln 2 plus cosine hyperbolic of ln 2 equals 0. Okay, I have f ln 2, this is 0. So I have cosine hyperbolic of 0. Here f of ln 2, this is 0 also, times 0 plus this things, which I don't know what is it. Actually, this is what I'm looking for. This is what I'm looking for. Plus cosine hyperbolic of ln2 equals 0. This is what? This is 1. I know cosine hyperbolic of 0 is 1 times this, so I have ln2 f prime of ln2 will be minus cosine hyperbolic of ln2. That will be e to the power ln2 plus e to the power minus ln2 over 2. Don't forget the minus sign. That will be 2 plus half over 2 minus 5 over 4. So this is my answer. Okay, y equal x cosine hyperbolic x squared, then find y prime at 1. Calculation, y prime, product rule, derivative of x is 1 times cosine hyperbolic x squared plus x times sine hyperbolic x squared times 2x. Now y prime at 1 will be cosine hyperbolic of 1 plus 1, 2 sine hyperbolic of 1. Okay, what is cosine hyperbolic of 1? That will be e plus e minus 1 over 2 plus 2 e minus e minus 1 over 2. So that gives me e over 2. This is cancelled plus e plus half e minus 1 minus e minus 1. So I have 3 over 2 times e minus 1 over 2 e inverse. E to the power minus 1, I mean. So it will be 3e over 2 minus 1 over 2e, which is this. Okay, y equals tan inverse of sine hyperbolic. What is the meaning? The relative change was this. They want y prime at 0 equal what? So I'll find y prime. That will be 1 over 1 plus sine hyperbolic square times derivative of this, which is cosine hyperbolic x. What will be y prime at 0? It will be 1 over 1 plus sine hyperbolic square at 0 times cosine hyperbolic at 0. I know this is 1 times 1 over 1 plus 0. That will be 1, and that will be my answer. Y could look at the base 2 of secant hyperbolic x. Find this. So I need to find y prime. Y prime will be what? Over secant hyperbolic. Okay. Ln2 here. Here I have minus secant hyperbolic tan hyperbolic x. Okay. Here? Yeah, 1 over. This is u. So 1 over u ln2 times derivative of u, which is this. So now this is cancelled. So I have minus tan hyperbolic x over ln2. Y prime at ln2 will be minus tan hyperbolic at ln2 over ln2. That, or let me say note, tan hyperbolic of ln2 would be e ln2 minus e minus ln2 over e ln2 plus e minus ln2. That would be 2 minus half over 2 plus half. That will be 3 over 5. So this will be minus 3 over 5 ln2, which is this. If sine hyperbolic equal minus square root of 3, they want secant hyperbolic. I know from this, cosine hyperbolic minus sine hyperbolic x equal to 1. So cosine hyperbolic square is 1 plus sine hyperbolic square. That will be 1. That will be 4. So cosine hyperbolic plus or minus 2 cannot be negative because I know it's from 1 to infinity. So that means secant hyperbolic will be here, and that is the answer. Actually, these cannot be solution because secant always between 0 and 1. I know this one is 1, this one minus 1, so it's minus 1, that will be 2. We know from the limit from the graph. If x equal cosine hyperbolic ln x, yeah. What will be f prime? I need f prime and then substitute at 1/5. Or before that, I can simplify f of x. That will be cosine hyperbolic ln x. That is e ln x plus e is minus ln x over 2. That will be x plus 1/x over 2. That will be x squared plus 1/2x. Or that will be half x plus 1/2x. So f prime would be half minus, this is what? 2/4x squared, which is half minus 1/2x squared. Right. Is it? Squared plus 1/2x. That is x over 2, which is give me half, plus 1/2x. So it will be f prime at 1/5. That would be half minus 1/2 times 25. That would be what? Can take half, common factor. I have 1 minus 1/25. That yeah, 25 minus 1. I'm missing something somewhere. No, wait a minute. I'm substituting at 1/5, not 5. So that will be 1/25. So it will be half minus 25/2, which is minus 24/2, which is minus 12. Yeah, I'm substituting at 1/5, not 5. Yeah, I think, yeah, let me stop here. By the way, these ones are, we need, what do you call it? L'Hopital's rule. So the first one, I think we don't need the L'Hopital's rule, but the second one, we need the L'Hopital's rule. So let me do the first one and then I will stop. This one, we do the limit, you have infinity over infinity. Infinity over, yeah, infinity. So I try to do it by opening this. So I'm getting what? Yeah, I think they need the L'Hopital's rule. That would be 6ex plus 4x over ax minus es minus x. Okay. I have infinity over infinity. We differentiate. Yeah. Do the L'Hopital's rule. I'm getting what? Ax, 6ax plus 4 over e to the power x plus e to the power minus x. Now I can take e to the power x, common factor in the numerator. I have 6 plus 4 is minus x. I take it here also. I have e to the power x, 1 plus e is minus 2x. Okay, so this is cancelled. So this is as it goes to infinity, it goes to 0. This is goes to 0 also. So that will give me 6 plus 0 over 1 plus 0, which is 6. So this is my answer. This one for sure I need derivatives. Also here I use the derivatives rule just to move from this one to this one. Let me continue to do some more problems, and then I will stop. Let me do 2 or 3, 4 problems. Okay. Now this is integration. I have f prime equal this. I want f at ln 2. So I need to find f first. What will be f of x? Cosine hyperbolic plus 2 sine hyperbolic plus c. Don't forget the c. F at 0. Cosine 0, which is 1, plus 2 times plus c, that will be 2. So c equal 1. So f of x is cosine hyperbolic x plus 2 sine hyperbolic x plus 1. F at ln 2, that will be e ln 2 plus e minus ln 2 over 2 to e ln 2 minus e minus ln 2 over 2 plus 1. That gives me 2 plus half over 2. This is cancelled. Plus 2 minus half plus 1. That gives me what? 5 over 4 plus 3 minus half. 3 minus half is 5 over 2. So that 10 over 4, so that 15 over 4. That will be the answer. If x equal this, find f at. So I have f of x is 1 plus e to the power x plus minus e minus x, e to x plus e minus x over 1 minus e to the power x minus e minus x over this. This is the tan hyperbolic. That will be e to the power x plus e minus x plus e to the power x minus e minus x over that over e to the power x plus e minus x minus e to the power x plus e minus x over the same. Very clear this is cancelled. I'm getting also this one cancelled and this one cancelled. So I have 2e to the power x over 2e minus x. So that will be 2 cancelled. I have e to x. So it will be f at half. It will be e2 to the power half. E to the power 2 times half. That will be e to the power 1, which is e. Calculation, nothing is there. I think we did this before. Let me do it quickly. That will be x minus 1 over x. That will be x squared minus 1 over x squared plus 1. That will be the answer. Okay, cosine hyperbolic equal 5 over 3, and x is positive. Yeah. I'll do these two, then I'll stop for sure. Notice x is positive. Okay. So for sure, I have secant hyperbolic is 3 over 5. So this is wrong. I can find sine hyperbolic through this. Equal 1. So I have 25 over 9 minus this equal to 1. So sine hyperbolic square will be 25 over 9 minus 1. That's 16 over 9. So sine hyperbolic plus or minus 4 over 3. I'll take the plus from the minus. By the way, this is not correct at all cases. Why I will take the plus? Because if you notice from the graph of sine hyperbolic, If x is positive, sine hyperbolic is positive. If x is negative, sine hyperbolic is negative. Because of that, he gave us this information that x is positive. So from here, I'm getting the sine hyperbolic is 4/3. This is wrong. And for sure, this is wrong. So now I'll find tan hyperbolic, which is sine hyperbolic over cosine hyperbolic. That is 4/3 over 5/3. That gives me 4/5, and this is my correct answer. Okay, let me do this. The last one. From this, I get secant hyperbolic square is 1 minus tan hyperbolic square. That is 1 minus 16/25. That is 9/25. So secant hyperbolic 3/5. I'm taking the positive. So cosine hyperbolic 5/3. Yes. Yeah, I think we did many slides. Let me stop the recording now. Thank you.